Welcome. In this rather short, hopefully sweet demo, we're going to have a look at the life cycle of an Android app and how we can get some hooks into it in terms of our actual code itself. So we'll have a look at the code. This will be made available to people by way of a demo, and it's going to be within the demos.app for the life cycle test and the life cycle test fragment. So we have two particular files that we're interested in. So we'll just do a quick walkthrough of the code, and then we'll have a look at how the thing runs. In essence, here is an activity and it's a fragment. We want to show that both of them have, in essence, the same types of life cycle, and that any fragment that is attached to an activity will sort of filter through the messages, so that if we do something with the activity in terms of its particular status, we do the same thing with the fragment too. For our lifecycle test here, so it's a type of single fragment activities. This is just a helper class. It's an activity whose view is a single fragment. So it just simplifies the process of displaying it. We're going to have a static variable for an activity counter. Generally, you should shy away from using static unless there's really good need to use it. There is here, in as far as activities can be created and destroyed, and we want to measure, or at least to identify, whenever that happens. So it generally happens not so much behind the scenes, but it may not be visible that what we're looking at is actually a completely new activity object that's been recreated. So we're going to have a counter here that will just count up how many activities have been created for us. Method create fragment is the one that is returned from the base class, so it just simply says, okay, let's return a new fragment for it. The methods that are really of interest for this particular demo are create and destroy, start and stop, pause and resume. They're all the main lifecycle methods that can happen. And whenever we create something, we're going to create our static counter to say, okay, here's a new activity that's been created. And we're going to create a notification message saying activity created. And then we call our superclass. It's a good thing to do to make sure we do whatever we do on default of creation. When we destroy something, we're just going to print a message, activity has been destroyed. Ditto with start and stop, we'll print messages. Pause and resume, we'll print messages too. So whenever they happen, we're just going to say this method has been called. We have a few notify methods down here. When we notify, we want to display something on on the screen to let us be able to see it. Now, because this is an activity, is actually the fragment that will contain the element that we want to display to. So our notify method here has to go and get the fragment and actually to display it. So when we call notify, we'll go to the fragment manager. We'll try to find the fragment that is attached to this particular activity. Now, this should give you pause at this particular point, because at this particular point, when we've just created it, we haven't created or added in any fragments, so there will be no fragments attached to it. So whenever we try to get the fragment, this may be null. So it's just to be mindful that if there is no fragment attached, we'll get a null fragment out. You'll see the significance of that whenever we have a look at this method. So lifecycle test fragment, this is our actual class. Notify is a static method defined within it. And we've declared it to be static because sometimes we'll need to call this method when we don't have any fragments created. So we do it through a static class. A little bit ugly, but it serves a purpose for this demo. And we're passing in, okay, what is the activity that called it? What is the fragment that we have attached to this activity? That could be null. What is the event? Whether or not the thing happened. Then a true flag basically indicating, okay, this came from the activity. But we'll have a look at that method in a second. ToString here, when we print out this particular activity, we want to just simply get the name of the class and to say that it is the first, the second, the third, or whatever instance of that activity as relevant. We have a look at our fragment class then. We see here that we have a corresponding fragment counter. So every single time we create a new fragment, we want to record that particular case. And you'll see there that fragments and activities, this demo, if we create one, we create a new one of the other. We've got our onCreate method, where anytime we create, we'll just say give us a new fragment counter, and we'll do a notification. OnCreate view, then we're inflating the view. This is the point at which we actually get something we can draw to. And as opposed to doing notification, all we simply do there is that we say, okay, we've got the text view, let's add our text to it, that we have a new view being created. It means the first time we call this method, we will make sure that we'll report the fact that we have created the view. We're not going to miss it. On destroy, we notify, start and stop, pause and resume. Again, all we're doing is we're displaying a message within this. Might as well have a look at the notify methods. Here's just notify one. We're calling our static method. We're passing in the activity to which this fragment belongs. We're passing in the fragment itself. It will exist at this point. The event, and false, indicating that this is a message that came from the fragment as opposed to the activity. So all of our display needs, if you like, happens within this particular static class. We're using a string builder. Talk about that in a second. And here we have our method. So this is the one that happens to display the different things on screen. String builder is quite important. You can view this yourself. We're concatenating a few strings together to give us the message overall. String concatenation is a fairly expensive activity. Strings are mutable. You can't actually change them. So if I concatenate a number of strings together, I've got to build, if you like, temporary strings to hold the concatenated version that is built up. But anytime I create a string that is a temporary one, I've got to throw it away and discard it. So it's actually quite inefficient. Using a string builder, it gives me a chance to populate it with whatever string fragments that I need, and then only at the end take the fully formed string out of it. So it's a more efficient way of doing it. So I build up the string, I log things out as well to the console, just by way of completeness. And I check to see down here, can I display it? And you'll see there, this is where we have our fragment if it's not equal to null. So in other words, if something tries to notify me, but I don't yet have a fragment available to display it, then I can't display it, I can't go on. Now, the event builder, it will still remember it. So the event builder is accumulating all of the messages that occur. So we won't lose it. Eventually it will display whenever we have something to display. But it's going to need to wait to that point. So if the fragment's not equal to null, then no point trying to display it. If our fragment does exist, then we can try to get the view that's associated with that fragment. And that also might be null, because there's a difference between the onCreate, where a fragment exists, and the onCreate view, which is the one that actually gives us something to display on. So we have also a final check here just to make sure that we have a view associated with that fragment. If we do, we find the text view and we output the event string to it. And again, similar to the previous one, we've a slightly updated toString method. So let's run this and we'll see what it does. Now this is the lifecycle test. So whenever I run my lifecycle test, we say we have a bunch of things appearing on the screen. Activity created, lifecycle test 1. We also got a fragment created. So that message was called. Fragment view created, that message was called. So as part of the creation, we called the onCreate for the activity, onCreate for the fragment, and onCreate view for the fragment. After that, we then started our activity, which, because we had a fragment attached to it, started the fragment. And we begin and start these here, and then we resumed the activity and resumed the fragment. And at that point, we're up and running. Now, if I were to go back, you may see just something quickly appearing there. So I have left that particular activity. It's gone. And if I were then to go back to my lifecycle test, you'll see here that we got the intervening messages that I had got to this point. I then paused the fragment. I got paused first of all. After I paused the fragment, I paused the activity. After that, I then stopped the fragment. I stopped the activity because I'm going out. And because I did go back, I discarded. I destroyed the fragment. After the fragment had been destroyed, I destroyed the activity. And at this particular point here, this is when I was back at the menu. When I next clicked on, okay, let's go back to our lifecycle test, you can see here we created a activity and it's lifecycle test 2. So it's actually a new activity object and you have the same sequence of things going back. Now, if I didn't destroy this particular activity, so I went back there to something else, I still notionally have this running in the background. I've finished whatever I need to do and I go back to it. So you see there we've come back, we had resumed it. Whenever I left, we paused it and we stopped it, but it was still running in the background, it wasn't deleted. Now remember, it could be deleted if we were running out of memory, the operating system could decide to discard it. And then whenever I came back and reinitialized this view, we started it and we resumed it. So it gives you a way of actually playing about with the life cycle and seeing which methods are called and which order are they called. And whilst we are doing a game, it nonetheless is going to be important to make sure that we do respect the life cycle and to make sure that our game fits in nicely with it, that we stop, we pause the game as appropriate. Next demo here, we actually will have a look at how we can do our update and draw loop, which will fit into a number of these pause and resume activities.